as part of CI/CD, continuous integration, continuous delivery deployment, we have discussed about Jenkins. So apart from Jenkins, we have many other build orchestration tools available in market. Like we have something called GitLab CI, and if you are talking about GitHub, means we have GitHub Actions, and we have something called Azure Repos, Azure Pipelines, AWS Code Pipeline. So we have other things in place, and so we'll be talking about GitHub Actions. I'll show you a demo as like how we worked on CI/CD pipeline Jenkins, same CI/CD pipeline with the same project. I can able to demonstrate with GitHub Actions as well, correct? But before that, I expect every one of you to cover the Jenkins module. This CI/CD is not completed, okay? Whatever we did so far, it's all, no, we perform the build and deploy that artifact to the target environment. But when it comes to the microservice architecture, right, we never deploy the application artifact directly to the target environment. We have to containerize it, okay? So that is what we will deal with containerization here. Containerization using Docker. So this is what the next module we're going to cover. Once we complete Docker, we'll be discussing about Kubernetes as well. That is a container orchestration tool. So these are the two important concepts we'll be covering in this module. And once we complete this containerization and Kubernetes, I will again come back to Jenkins and I'll show you how to integrate this Docker and Kubernetes in a Jenkins pipeline. So it is not that we are going to, leave the Jenkins model as it is, because CI/CD means goes till deployment. Whether you want to deploy your application artifacts or we can deploy your application images target environment, depends upon that. We can able to integrate, and it is a continuous, enhancement process. So whenever we talk about the orchestration, Jenkins is a build orchestration tool. So as part of your CI/CD process, what are all the tools you're going to use, you should be able to integrate with Jenkins. So now let's begin with the containerization process. Listen carefully. I'll come back to this GitHub Actions and Jenkins. Okay, after completing this module, we'll integrate this with Jenkins. Now, what is containerization? So when we talk about containerization, it is a process of packaging the applications along with its dependencies. That's it. It is just the process of packaging application along with its dependencies. That is containerization. So what is packaging? What is a dependency? We'll see one by one. And it is mainly used to deploy microservice based applications. If it is a monolith application, you can rely on your traditional method. But whenever you want to deploy your microservice based applications, it is recommended to have with containers. So what you're going to do with containers, how to containerize this, what are all the process we're going to follow here? That is very important to understand now. So when it comes to the containerization, right, we can able to consider containerization on two perspectives, whether you're going to use it on infra perspective or on deployment perspective. So when it comes to the infra perspective, we have a separate route. And when it comes to your deployment perspective, we have a different route. So there are a huge scope when it comes to your containerization. But the point here is, before you actually work on containerization or packaging applications, you need to be clear with some terminologies. So ultimately, what is a deployment? Deployment is just a process of effects from one server to another server, right? That is what we did in our previous module. Like we have copied the artifacts from the slave node, that is a build server, to the Tomcat server. The artifact has been copied to the target environment. So here in this case, we have used three different servers. One is your Jenkins master node, your build server, that is slave node, and then your Tomcat server. So all these things are virtual machines. It is a computing device or environment, we can say, right? So in order to work on this containerization or Docker, first we need to be very clear with the term virtual machine, and another important term is containers. So these are two important terminologies we need to be very clear before we implement. So what is a virtual machine? Why we use virtual machine? What is the need for it? VMs are considered as hardware level virtualization. In short, VMs are considered as a hardware level virtualization. If you want to understand it better, I'll give you one scenario. Consider I have a computing device. The laptop, whatever I'm using here, this is my Windows-based machine. So assume that this is my computing device with the underlying hardware, with a CPU and memory, right? Assume that I have around 16 GB of RAM in my machine, and I have around 2 CPUs in my configuration. And I have installed Windows operating system. Windows 11 is up and running here. And on this Windows machine, I can able to run only the Windows applications, right? The applications, whatever I'm executing, it's all Windows-based applications, correct? Right. If I want to run any Linux application, or consider I want to handle a batch for some Linux-based projects, and I need a Linux machine. Can I run that Linux application on this Windows OS directly? Is it possible to run any Linux-based applications here? So if you want to manage any other operating system directly, you cannot run on the base OS. Like if you want to run your Linux-based applications or any other OS-based applications, it is not possible to directly run on it. So what I need is, I need to create a virtual environment. So on top of this operating system, I'll be installing one middleware product. It is called as an hypervisor. Okay, so hypervisor is a middleware product, and using this hypervisor, I can able to create some number of virtual machines. Like consider this is VM1. 2, 3, and 4. And each VM can have its own operating system. Like this can be my Linux Ubuntu OS, and this can be my Linux CentOS. Or if I want, I can have another version of Windows OS itself, or I can have a Mac OS, right? So virtual machines are used to run some operating systems. And on top of this, you can able to run some applications. Like I can run some Linux-based applications here, correct? So whenever we install Hypervisor, the purpose is to create some virtual machines. And each VM will be running in its own dedicated address path. It will be having its own address space, and it will be running its own OS and implementing it. But the point is, in order to run the VM, you need some underlying properties of the hardware, because it is going to initiate one OS. So to run the OS, we need some hardware components. Like we need some CPUs and RAM is required for each and every OS. So from where these VMs are going to procure those detail, that hardware means it will be utilizing the underlying hardware. So how many OS we have in this machine now? 5. Including the base OS, we have 5 operating systems. So all these 5 operating systems are going to utilize or share this underlying computing environment, like CPU and memory to be shared. And even if you're not running any application here, if your VM is up and running, automatically the volume or the underlying resource will be consumed by that VM. Assume that I just started this VM2. I'm not running any application there, but still that VM is up and running. It is a running state. Though you're not running any application, it will consume the underlying hardware resources. Correct? That is another important thing to consider. Like this, as per my need, I can able to create any number of VMs using the hypervisor. So the point here is, assume that I can able to create 4 VMs here. If I want to add 5 more VMs, is that possible? It is possible, but the point is, it might degrade the performance of the machine. Why? Because we just have 16 GB of RAM and just 2 CPU. It is practically not possible to use this limited resource to support nearly 10 operating systems, right? If you can't run all the 10 OS simultaneously, it will impact the underlying OS and the entire computing device will be unreachable state. So to overcome this, what I should do, I need to add more resources to my architecture. I can add more CPUs and I can able to add more memory, RAM. That's what scaling of your devices. To do this, I need to invest. I have to make some upfront investment. Correct. Before I start the VM, I have to procure the underlying hardware components. I have to configure it, which involves the upfront investment. So without any investment, if I want to avail these things, the only option is I can adopt for a cloud service. So that is the reason we are all using the cloud-based, virtual machines. If you want, you can able to install. Even I have a VM hypervisor installed on my machine. I have Oracle VirtualBox installed on this machine. It is one of the hypervisor component, and I have a Linux-based OS also up and running. I can do that. But for a larger scale, I cannot rely on my machine because this can be considered as your on-premises environment. In this on-premises server, there are a lot of limitations in your hardware, your storage capacity, everything matters. If I want to scale up, it is not easily possible to scale up. So that is the reason we are relying on the cloud platform. In cloud platform, if you create any account, like if you choose any service provider like AWS or Azure or Google or DigitalOcean, you can able to quickly create an account there and you can avail their services. You can quickly scale up or scale down, add more resources or delete the resource, and the payment, the charge, whatever they're going to give, right? It is based upon the usage. Got it? No. So this is about your virtual machine. So the main disadvantage of using virtual machine is the resource consumption. Even if you're not running any application, your resource will be consumed in VM, and end of the day, it leads to billing. So if you want, I can give you those explanations here first. So VMs are called as a hardware level virtualization, and VMs are created using hypervisor. Correct? It is created using hypervisor. And another important thing is the VMs are used to run the operating system by default. Like even when you create your VM on AWS, what you did first, you choose your AMI, whether it is Ubuntu or Amazon Linux, right? So it is basically used to run the OS, and on top of that OS only you can run any of your applications. So VM continue to run even if there is no application or task. So that's what. And that is the reason we expect the people to manually go and stop the instance. Remember, I told you, right? Whenever there is, if the VM is not in use, just go and stop it because it will consume a lot of resource behind the process. Now, another important thing is the VMs, whatever you use, consume more CPU and memory, and it consume more time to start up. Even if you try to start your virtual machine on your AWS platform, it takes some seconds, it takes some time to start and make it up and running. So because the bootstrapping requires some time, it has to start boot up your OS underlying machine, and it has to come up. So it takes some time to implement. So these are the important scenarios or points to be considered while working on VMs. So in a typical environment, right, in your legacy monolith application environment, this is not a big deal because one application will be dedicated with the resource and you are going to use the resource for a lifetime. But in microservice application architecture, one application will be having thousands of microservices. To deploy thousands of microservices, I can't create 1,000 virtual machines. Correct? Because each and every VM is going to consume a lot of resource, time, as well as cost. So to overcome this, what we're going to means we can go with the containers. If you want, I can give you a straightforward comparison here. So these containers, whatever we're talking about, containers are considered as the OS level virtualization, not the hardware level virtualization. Say for an example, I'll come back to these points in some time. Okay, let's take another example. Consider I have a computing environment with the underlying hardware and the base OS. It can be anything, your Windows or Mac or Linux, whatever it is. So to create a virtual machine, what we did here, we have used Hypervisor. Similarly, if you want to create any containers on your computing environment, we use a component called Container Engine. So Container Engine also, it's a kind of middleware product that will be installed on top of this operating system. And using this Container Engine, we can able to create some number of containers like container 1, 2, 3, 4 kind of thing. And the main advantage of containers are used to run the application basically. The containers are basically used to run some applications, not the operating system. If you run any container without any application, it will immediately go to exit state. Or consider a scenario, I'm running my container, the application is under execution. Once the execution is completed, automatically the container will go to exit state. It not wait or it won't hold the resource as like VM. But VMs are not like that. If you run any application, even if the application execution is completed, the VM will be available, active. But the containers, once the application process completes, automatically the container will go to exit state. It means it is going to release all the resources that are consumed by the container and application. Easy? And since it is not used to run any OS, it actually speed up our deployment. If you want, you can able to quickly start your application. You can run your application without any, what you call the delay in startup. And another important thing is any container you deploy or create, it runs in its own dedicated address space. As like a VM, this containers also will be having its own dedicated address space. And those address space allocation is basically procured from this underlying OS property. Any operating system we call, right? We have something called the core of the operating system. The core of the OS we call it as a kernel. If it is a Linux-based machines or Unix-based machine, we call it as a kernel. And Mac also we call it as a kernel. And even Windows we call it as a registry, Windows registries. So the core of the kernel, right? We have two components. One we call it as a namespace, and another thing is your control group. So these are the two important core OS properties which helps to run your applications or process in its own dedicated address space. So it means if you run any application in this container, the scope of the application is within the container. Even the underlying container or your container engine or the underlying OS cannot understand what you're actually running this container. The scope is completely private. If you want to share it with other containers, you can explicitly establish a network or communication and we can share the details. That is a different story. But by default, containers run in its own dedicated address space and it is completely isolated. So that level of isolation will be created with the help of these two core components. All right, coming to this explanations here. So as I said, containers are considered as a OS level virtualization because it is going to utilize the underlying properties of the OS called namespace and control group. And containers are created using container engine. Let's say if you want to use Docker means you'll be installing Docker container engine. If you want to use Linux containers, you can install Linux container engine. Like that, we have a lot of container engines available in market and it is used to run the applications or task, not operating system. This is very much important to consider. If you want to add one more point here, if the application or task completes, the containers will immediately go to exit state. Okay, two terms are there. Sometimes what happens, we'll try to run the empty operating system as like VM. If you simply start your container without any task, it will immediately go to exit state. And because of this properties, your containers will be, faster. It will compared to VMs. So let's say in one particular machine, if you want to start your application, first you have to boot up your machine. That OS should come up and running and it will enable all the startup tasks and then only you can run your application. But the same application, if you want to run in a container, it will not wait for anything. Okay, immediately within few seconds, your application will be up and running. So your containers are faster when compared to VMs. And the container consumes less resource and as well as it consumes less time to start up your application. Easy. And another important thing is by considering these properties, we can say like container advantages, right, when compared to VM, but it is not possible to completely eliminate the VM. Okay, we are not going to use containers to eliminate the VM, but point here is using containers, we can reduce the number of VMs. That's it. So you can able to consider like this. If my Windows machine. In this task manager, you can see there are a lot of process some background process and some foreground process up and running, right? These are the applications I just opened. It's all foreground applications. And apart from this, there are a lot of background applications up and running. Correct. And each and every process that is running on your computing environment, it is not only in Windows OS, even if you take your mobile phone also, there are a lot of background applications up and running. So each and every application or the task consumes CPU, it consumes a memory, and it runs in its own dedicated address space. So within the operating system, the core component we call it the namespace and the control group that provides this dedicated address space to run your task. So these two properties are utilized by the containers to run its own task within that. Easy. So tomorrow, whenever we create any container, the container requires these two components from the base OS to create an isolated address space to run the containerized applications. All right. So this is about your virtual machines and the containers in detail. And now we'll talk about this containers and the process of containerization in detail now. Okay, if you want, I can give you some use case. Okay, before we actually get into this, I'll give you some real-time scenarios. I think that will be helpful for you to relate the things. But keep this point in mind before we get into this. Let's talk about some use cases. Okay, so if you want to work on this containers, right, it can be considered on two perspectives. One is at the infrastructure perspective, and another thing is at the development or this deployment perspective. So there are two areas where we can able to use this containers. So when I say infrastructure perspective, you need to understand how these containers are going to helpful in the infrastructure. If you want, I can take it from your known thing itself. In your last module, you were using Jenkins, right? And we are using Jenkins slave nodes, remember? So what is the need for these slave nodes? I told you in the Jenkins architecture, we can have a number of slave nodes created, right? So what is the need for slave nodes? And what is the need for Jenkins master, first of all? Slave nodes are ultimately used to perform build. It is used to build the application. Why we need dedicated VM means each and every VM can have its own build tools. Like this VM1, the slave node 1 is dedicated for my Java application build, where I can install the Maven and other build tools and the dependencies and create the Java-based application artifacts. Similarly, Node 2 is meant for my Python-based applications. Node 3 meant for .NET-based applications. Got it? Like this, consider at enterprise level, I have nearly 100 different types of applications. I mean, the technologies I'm saying. And I want to build all these 100 different types of tool stack. So practically, do you think we need 100 slave nodes to execute those builds? See, we are from DevOps team. If you need any computing device or resource, we will not have any direct access to provision the resources. Okay, we have to place a request to your infra team, and based upon the approvals only, we can able to make it further. So the point here is, in order to build your applications and the artifacts, practically we cannot rely on these many VMs. So what we can do here is, instead of relying on this virtual machine, I'll give you one small use case here. Let it be like a Jenkins master node for now. If you want, you can run your Jenkins on your container itself. That is a different story. But still, what I can say here is, consider I can have a build server, Jenkins slave node 1. After all, this is a VM. And in this VM, instead of directly installing all the build tools, what I'm going to means, I'm going to install container engine. If I install container engine, what is the benefit? What is the purpose of container engine here? So on this VM, if I install a container engine, using this container engine, I can create a container like container 1, 2, 3, 4, 5 kind of thing. And I can able to use these containers to build these applications. Container 1 can be used to build my Java-based application, create the artifacts, and then publish it to the artifact repository. Like this, instead of creating the virtual machines for each and every application build, I can have one VM and puff build here. So now if you consider this infrastructure perspective, we are going to utilize this container or containerization techniques to reduce the number of VMs, right? With this, we can able to save a lot of cost. Understood? So that's the reason I told you containers are used to reduce the number of VMs. It is not like we are going to completely eliminate the VM. Here in your previous case, you need around 6 VMs to perform this task. But now, just with 2 VMs, we can able to achieve it. So when you consider containers on infra perspective, it will be very much helpful to reduce the number of VMs, and it saves a lot of cost end of the day. I'll practically show you how to implement this. So this is the first scenario for using containers on infra perspective. So you can able to take it on any infrastructure, okay, for any type of application builds or even deployment environment. Here, this use case are given for build environment. Tomorrow, if you want to implement the same for your test environments, like consider I have a dedicated QA environment. Previously, you might be using a number of QA servers. So you can able to reduce all those QA servers and run your QA testing through containers itself. It's possible, right? Even the same techniques can be implemented even in a production environment. Instead of having dedicated production servers, we can able to reduce the number of production servers and run your applications in the form of containers or pods. I'll talk about Kubernetes, okay, how you can implement your containers and containerization in production level implementations. Now, the next scenario is, consider at the development or deployment perspective. So when I say containers, I said it is a process of packaging application along with its dependencies. So consider a scenario, we have a developer. So what's the role of developer here? They create the source code, build, and as part of build, they create the artifacts. Hope you remember, right? The artifacts are created. It can be anything like my web app.war file, anything like that. So once the artifact is created, what is the next step? What would you usually deploy to target environment? It can be your QA environment, for example. So now the artifacts, whatever you created in your build environment, it will be copied to QA environment. Let's say this is your, all these things are happening in your low environment, thus this is your QA environment. So in this QA environment, this artifacts will be deployed. It is copied and it gets executed. And once the QA testing is completed, the same artifacts can be deployed to your UAT and even to your production. So hope you can understand the workflow, right? How the artifacts will be promoted to the higher environments. Now the point is, as a developer, I have prepared these artifacts, and before I promote the code to QA environment, I'll be doing a thorough testing here. I'll be doing all sort of unit level testing using a JUnit testing tool or TestNG. I can able to perform some sort of testing here. And to test my web application, what I need a web application server. Assume that I use something called Tomcat here. Using Tomcat web application server, I run this application and I'll do all sort of unit level testing. And once the testing is completed, once all the test cases are completed, then only I can deploy this to QA environment. So to run this application in my lower environment, I need this web application server. Assume that in this lower environment, I use JDK 17 and I use Tomcat 8.5, for example, to run this web application. And the application execution also is very much successful. We are good with the result. Now the same artifacts, when it enters to the QA environment, the QA testing team has to run this application, right? So for that also they need this Tomcat web application server to be configured here, correct? Yes or no? We need this web app server, right? In the target environment, correct? So now the point is, assume that in your QA or a higher environment, instead of JDK 17, they have just JDK 11. Instead of Tomcat 8.5, assume that they have Tomcat 10 version. And this war file has been deployed to this particular environment and they want to run this war file based upon this version. Will it get executed or not? We can't say no directly. We can't say yes also, right? There might be some compatibility issue. We can't always say no because there might be some dependencies. There might be some compatibility issues. Assume that the artifacts, whatever they've created, it is based upon the JDK 17 and they want to run it in JDK 11 means it might not be successful. It is not the issue with the application artifacts. It is an issue with the infrastructure. That infrastructure is not enabled with the required tools. So now it is not the problem with the testing team or with the development team. It is at the deployment level. The target environment should be configured accordingly. Same situation occurs in the UAT as well as in the production as well. The applications, whatever successfully in the lower environment, it might not be successfully started in the higher environment because of the compatibility issue. So to overcome this, what we can do, we can't expect the infra team to install the same set of tools in all the target servers. If you're working on your traditional monolith application architecture, it's fine because you'll be running one application as a whole. So before you deploy anything, you ensure that the tools are installed and configured in all the target servers. But in microservice application architecture, the entire application is divided into various microservices. There will be thousands of microservices for an application. And each and every microservice will be having its own tool stack. One can be with JDK 17, one can be with JDK 11, one can be with Oracle JDK, or one can be with Open JDK. A lot of differences, a lot of version level differences and compatibility there. So practically it is not possible to install all versions of JDK and all versions of Tomcat in your target server, correct? So to overcome this, what we do means we take an approach called containerization. So here on development or deployment perspective, we can use a concept called containerization. So I said containerization is a process of packaging application along with the dependencies. So now the application is this one. So what I'm going to do here is before I deploy to target environment, I'm going to package this application along with the dependencies. So what are dependencies for this application now? This JDK 17 and Tomcat 8.5 is a dependency. Package it and give a valid name of the package, image v1.0, something like this. So the war file, whatever we created, it is an application artifacts. I just want to create an image out of it. So this image is just a static file. The package, what we call here on container or Docker perspective, we call it as an image. It's an application image. There is a difference. Okay, this I consider as an application image and this I consider as an application artifact. Got it? So using this application artifact, we are going to sum up all the dependencies and create one image out of it. Once this image is created, we are going to deploy that image directly to target environment. Image to target environment through container registries. So now you can see there are a lot of new terminologies coming in. Image, container registries. right? So container registries are nothing but like, it's like environment where we can able to maintain or version control our application images. I'll talk about this in detail, but as of now understand, once the image is created, that images, instead of directly deploying application artifacts, you're going to deploy this image to the target environment. Now, instead of deploying the WAR file, when the image enters into the target environment, this image is already having the dependencies along with it, right? So it means even in the target environment, whether you have JDK installed or not, whether your Tomcat installed or not, that is secondary. Using this image, I'm going to create one container and I can able to run that application image in the container directly. Similarly, in all my target environment, I'll be able to deploy this and run that application as a container. So with this, you no need to worry about the infrastructure, okay? Whether your infrastructure is enabled with the proper required tools or not, that is secondary. We are just packaging it and deploying the application images, and it can be executed in any target environment. With this, you no need to rely on your tools compatibility and other stuff. So how this image can be created and how it can be executed as a container, how it can be maintained in a container registry. So all these things we're going to learn in this module now. That is what a process of containerization. So now, in order to work with this containerization, right, there are a lot of things to be considered. Okay, before you actually start your work, there are a few things. Like, for example, first let's talk about the terminologies, because we use some terms like images, container registries and all, right? So let's understand what are the basic terminologies we have here. Listen carefully. So the very first thing which I used here is a container engine, and we use one term called container image, and also we use one term like container itself. We use a term container registry, correct? This one. And also we have some terms like container repository, right? So these are some terminologies you need to be very clear before you actually start creating this. So ultimately, container engine, right, it is used to create the container images, containers, and used to manage, or I can say like it is used to create and manage the container images and containers, in short. So if you want to use Docker, means you need to use Docker container engine. Or if you want to work on Linux based containers, you can use Linux containers. So a lot of container engines are available in market. It's okay. So we'll be installing Docker container engine and practice all those things. In order to work or in order to create any container, we use a term called container image. So container images are nothing but is a static file. Okay. Container image is just a static file that defines the properties and dependencies of the container or application, I can say. Correct. And important thing is the container images are non-executable and it composed of various layers. Correct. And these layers are created using the instructions like Docker. If you're using Docker engine, means we can use the Docker file instructions. So I'll show you, I'll demonstrate each and every point during a demo. So just keep in mind, it is just a static file and it is non-executable. It is just to define the properties and the dependencies of the application. For example, consider this is my application, and when I create an image, this image is going to have the properties of the application along with the dependencies, and directly you cannot run the image. That's why it is called as a non-executable entity. And each and every incremental change that you make in this particular image, we call it as a layer. And to build that layer, we use some instructions. I'll show you how to build that layers and all. Now, the next important thing is about the containers. So these containers are called as are the executable units of container image. Simple as that. If you want to execute any image, that image will be executed as a container. Correct. So you will be passing an input as container image, and based upon that, you'll be running a container. So this process of creating and managing containers is what done by your container engine. Easy. And another important thing is the container registry. So these container registries are nothing but you can consider like a repository. Okay, it is basically used to manage, or we use a term like version controlling. Control the container images. Simple as that. What is the purpose of GitHub? So whenever developer creates any new version of the source code, it can be version controlled in your GitHub repositories. Similarly, whenever you create any version of your application image or a container image, these versioning can be maintained in your container registry. So we use one container registry called Docker Hub. We are going to use Docker Hub as a container registry to manage our images. Easy. And another important thing is your container repositories. So these container repositories can be considered as a subset of container registry. Simple as that. So it means within your container registry, you can have a number of repositories can be created. Like say, for example, you have created a GitHub account. Once you create a GitHub account, within that account, you can create a number of repositories, right? Source code repositories. Like this, within your container registry, you can able to create any number of container repositories. It is a subset of the container registry. Clear? I'll show you how to create these container registries, and within that, how we can able to manage your container repositories and all. So if you're clear with these terminologies, then we can directly get into our implementation, that is working with containers. So in order to work on this, first thing you need to do here is we have to install container engine. So we are going to install Docker now. First, we'll see how to install Docker. And once Docker is installed, you need to work on the Docker CLI commands. So these are all the, like if you want to interact with your Docker engine or container engine, you'll be using this command line utilities like Docker CLI commands. Like if you want to create an image or create a container, whatever the action you want to perform, you'll be using this Docker CLI commands. And there are some concepts you need to be very clear, like how to create an image, how to create a container, how to log into the container and start utilizing the container resources, and how to manage your container data, the volumes, how to manage your containers and running as multiple multiple containers as a service. Like there's a lot of things we need to practice. And then the very important thing is your container orchestration. It can be a Docker Swarm or it can be a Kubernetes. And promptly we are going to focus on Kubernetes here. So this is the official page from where you can able to understand Docker. It's a very good resource to learn about Docker, to install, to specialize, to get expertise in this technology. So we are going to install Docker engine and we are going to install it in our Linux-based machine like Ubuntu. So these are the dependencies. Like we're going to use this docker.io for installation. And if you want to install on any other distribution, just the package manager on varies. Like instead of apt, there you might be using any other package manager like your yum package manager kind of thing. Simple. The installation command is very simple here. So in order to install, you use a command like apt install docker.io. Simple. So this is a command to quickly install your Docker container engine on your VM. So where we are going to install means we are going to install this in our, I guess already you have a VM, right? You must be having your slave node, Jenkins slave node. So you can use that VM instead of creating a separate VM. If you already have this resource, honestly, don't go and create another VM for this demo and all. Okay, so let's use the same because you must have done it in your Jenkins module to create a build artifacts and all. So start the Jenkins slave node and install Docker engine in that node. So let me log into my console. So if you remember in our previous module, in our Jenkins module, we have created one slave node, Jenkins slave node. Remember, I'm going to start that node now. Yeah, you can reuse the same. Don't launch another VM, okay? Unless you don't create a resource here. If you have it ready, you can use it in your slave node. So what I'm going to do here is I'm going to start connect to this machine now through mobile XTERM. So once you have your Ubuntu machine up and running as a root user, you can simply run this command apt install docker.io. That's it. So now you can see its installation is completed and you can use a CLI command docker version. So Docker version 24.07 has been installed on this machine. And once you have Docker installed, the next thing is we have to work with Docker CLI commands. So the first command, whatever we used here is Docker version to check the version of your Docker, right? Like this, there are some commands like Docker images, Docker ps, Docker ps-a. PS means process. So for example, consider if I use Docker images, it is used to get the list of images that are present in my local machine. As of now, there is no images, so it is empty. And if I want to get the list of containers, active containers, I can use Docker ps command. So this command is used to get the list of containers that are up and running. And once the containers go to exit state, you can't find the containers here. For that, you can use one tag called -a. -a means all the process, including the containers that are in stop state. So it is used to get the list of container images present in the local machine. And this is to get the list of active containers. And this is to get the list of active containers as well as the containers in exit state. That's what all. All right. So these are the basic commands we use to refer the containers and the images in a local machine. So now we'll see how to work with these container registry first. So we have something called Docker Hub. It is a web service where we can able to manage version control of a container. Okay, so let me get into that first. So here's the link. You can use this link to create an account. So if you're new to this, just click on sign up button. So get into this link and click on sign up button, enter your active email ID, create a password and register it. Same as like how you created your GitHub account. You can use the same email ID as well, no problem. Just create an account and ensure that you can log into this. While creating an account, it expects you some options like whether you want to install any desktop and all. No need to install anything. Just create an account for now. I already have an account. Let me sign into that account and here it is. So once you log into your account, this is how your account looks like, your dashboard. and this is my account ID. Loxai ETA is my account ID. And there is something called explore option where you can able to explore the list of images that are already published in this container registry. Let's understand, okay, this dashboard, like what are the options we have here and how to explore the images, what are the different types of images we can avail here, everything. So on this explore button, if you click on the explore, you can see we have some images already available here based upon the categories. Like if you want to explore based upon the category, you can able to select some images. Like if you want to relate it to your networking or web servers or operating system or any developer tools, you can choose a category and avail those images. And in general, the images, whatever we see here, right, it will be based upon these three categories. Like we have something called Docker official images, which are certified by Docker. And it is always recommended to use Docker official images which is officially certified with proper documentation, and it will be free from all vulnerabilities and other security threats. All right. And the Docker account, whatever you created, right, it is considered as a community account. And at enterprise level, if you want to use this Docker Hub, you can create an enterprise level account. That is Enterprise Edition. That is a paid service with additional security and scanning capabilities. And apart from there, something from the verified publisher or from sponsored open source services, images will be available. You can explore it. And there's a search bar from where you can search for the images. Like if you want to work on any of your application web servers, like in a previous module, we talked about Tomcat, right? So if you see here the Tomcat image, we have a dedicated image for Tomcat, which is official, Docker official image. So if you explore any of these images, you can see a detailed documentation about the image. What is that image all about? How to use that image? How to create a container out of it? And what are the various versions of that? The tag here in the tags, you can see the list of versions. Like image name is Tomcat, and this is the version number, which is called as tags here. And if you simply use the image name, it will always refers to the latest version. The latest version is something like 9.0.96, right? So if you simply say the image name, it refers to latest version. Or if you want to go with any specific version, use that version number as a tag. Easy. And just choose any of these versions and get into the version. Now we just enter into this version 9.0.96 version, and you can see these are the various layers of it. As I told you, images are just a static file which composed of various layers. There are nearly 20 layers available, and all these layers are built based upon the Docker file instructions like env, work directories, and other stuff. We'll see about all those things while working on Docker build option. As I want to understand, okay, how you can explore these images, and also you can see the vulnerabilities. There is no vulnerability identified because it is the official image. Similarly, if you want, you can able to explore other images as well. Like consider you want to set up your build environment altogether from the scratch using containers. Means you can able to search for any images like Ubuntu image. See, we have a dedicated image for Ubuntu. All right. Not only this, you can able to explore something like CentOS, right? Like this, we have some images available, so you can able to explore it. So now you can see there are some images already available in your Docker Hub registry. And I also said about something about the repositories, right? So when you say repositories, repository is a subset of your container registry. At your account level, you can see something called repositories tab. Can you see this? After this, you have something called repositories. If you click on repositories, you can see by default, based upon the account ID, when you create an account, based on account ID, it creates one repository. Okay, so in this repository only, all your images will be defined by default. If you want, you can able to create your own repository like this. Give a name of repository and a short description about it and make it as public or private. So what is the purpose? And in real-time environment, when we'll create repositories means, consider I have some application teams. I have some services. Some application teams might be having their own, application components, their own architecture, and they want to maintain their own repositories to manage all their content images. Means on application perspective, we can able to create some repositories. Similarly, for each and every team, we can have a dedicated repository. For each and every environments, we can have a dedicated repository, like a repository for test environment, repository for QA or UAT. Like that, we can able to maintain the repositories at the environment level or at the application teams level. Got it? Now, what we're going to do here is we are going to use some existing image from this Docker Hub registry and create a container out of it. For that, choose any image from the container registry, and we are going to use a command called docker pull command, docker pull. So this command is used to, this is to download the container image from container registry to local machine. Easy, because as of now, if you can see here, what is this? Docker die images. We don't have any images at this point of time, and we don't have any containers all in our machine. Now, let's download one image from container registry. You can simply say docker pull followed by the image name. So which image you want to work, whether you want to work in Ubuntu or CentOS or Tomcat, whatever the image you want to use, you can able to use that image name directly. See, this is the one. So this will download the latest version of that image into your local machine using Docker default. Now, if you say Docker images, you can able to see this image has been downloaded, the latest version is identified, and whenever you download any image, right, it will be having its own image ID. So this is what we call it as a image ID, that is used to uniquely identify the image along with the creation date and the size of the image. But it doesn't mean that we have created a container out of it. If you say docker ps, there is no containers created. So pull command is just to download the image from the container registry to your local machine, and based upon that image, if you want to create a container, you can use a run command. So here the example is docker pull followed by that image name, and optionally you can use a tag here, pull CentOS. Easy. Similarly, we have something called docker run command followed by the image name. So this command is just to create a container out of it. So CentOS is a base image, which is considered as a OS base of the operating system, right? So if I want, I can use the same image to create a container. So docker run followed by that image name like CentOS. See, this command has been executed. And if I see the container, I said docker run is used to create the container, right? So when I say docker ps, if I say docker ps-a, you can able to see one new container that is created based upon the CentOS image. And it was created 30 seconds ago and exited 29 seconds. That means within a second, the container goes into exit state. And this is a random name assigned to the container. This name and the container ID will be automatically assigned by the container engine whenever you create a container. If you want, you can able to give your own name as per your requirement, but the container ID cannot be assigned at runtime. It will be done by the container engine. Can you able to figure out why this container is not up and running? Whenever we create any container, our intention to execute a container, right? But it is in exit state now. What's the reason? It is not like we are not running. We are running the container. We are given a command called docker run command, and intention is to run the container. But unfortunately, it is not having any task to perform, right? This container, it is not having any application or task to perform. So that is the reason it has started the container, and within a second, it went into exit state. So that is the default property of a container. Remember, so containers are used to run the application or task, not the OS. The CentOS is a base without any task. So if you try to run a container without any application, it will immediately go to exit state. That's what happened now. Understood? If you want, I can execute the same, use the same image and create one new container with some task. Let's say I can use the same container image like docker run CentOS, and I can give some runtime command like sleep. It will be for 20 seconds for now. So it means the container is under execution. If I want, I can create a duplicate terminal here. You can see the container started 14 seconds ago and it's still up and running. 18 seconds, 19, and now it is over. So we have created one container with sleep command 20. That means for 20 seconds, I want to hold that task, right? So there is some task that is up and running for 20 seconds. Once the 20 seconds completed, automatically container goes to exit state. And if you say docker ps, you won't find that. But if you say docker ps-a, the latest container, whatever we created, it was running for 20 seconds and go to exit state. So now you can understand another important thing here. While running a container, you can directly give docker run followed by the image name. When you do that, it will run the container based upon the default command. If you want, you can able to pass some commands at runtime. So how you can able to pass the commands at runtime means it depends upon the property of the image. So if you go to the CentOS image here, the tag, and this is the latest version, for example. So these are the layers of your container image, right? So the last command cmd bin bash. So this is what gets executed in your previous case without any task. Now we just pass some runtime command. With that command, it has executed the container and it reaches 20 seconds and go to exit state. And another important thing you should understand here is while that container is up and running, you are unable to access the terminal. Have you noticed? If you want, I can try again. I'm going to start this, create one new container, and now the container is up and running. I could not access the terminal. That's the reason I just open a duplicate terminal and try to capture this container details. So what it means, whenever you run any container, by default, the container runs in a foreground mode, which will hold the resource, hold the terminal. Once the execution is completed, it releases the terminal. So when it comes to your docker run command, there are three things to understand. One is the mode of execution. So here we have a Docker container mode of execution. So very first thing is we have something called foreground mode. It is also called as attached mode. And the second mode of execution is background or detached. And third mode of execution is interactive mode. So these are the three modes of container execution. So this foreground mode is a default one. That's what you have seen here. When you simply say docker run command, it runs the container in a foreground mode. Whenever the container is running in foreground mode, that terminal will be locked by that container. correct? So I don't want to use this terminal for any other process. I just want to hold it. I just want to run this process as a foreground process. So for that purpose, I can able to run it in a foreground mode. Or sometimes we need to run some process in a background. We need to run some content in the background as a background task. So that can be executed as a detached mode. So the syntax for this foreground mode is docker run followed by the CentOS. Simple. For the image name, whatever you're given here. And for this background mode, you can simply use docker run -d followed by that image name. So for the same command, if I use -d followed by CentOS and sleep for 20 seconds, -d means detached mode. It just detaches the execution and runs in the background. See, it started. If I say docker ps on the same terminal, I can able to see that process at the backend. So this container gets created and it is running in a background now. So this is detached mode. So you can able to decide, okay, in a real-time environment, we'll be creating a number of containers. We'll be running a number of process. So whether you want to run those process as a foreground process or background process, that will be decided by this mode of execution. It is same as like what I showed you, right? Earlier I was showing a task manager, right? On my Windows machine, I have some process that are available and running as a foreground applications. These are the foreground tasks or a process up and running. And these are some background process. These process up and running, but still it is not visible. We cannot, evidence it like directly from our dashboard or from your desktop, right? But these things are running in a foreground mode. You can able to access one application at a time. If I open this document, I can access it. So similarly, your containers also, it can be executed in a background mode or in a foreground mode. And apart from there is something called interactive mode. So this is the mode where we can able to interact with the container, log into the container. Like we have something called -it, interactive terminal in a bash mode. So if I run this command here, docker ps -a. So these are the containers we created so far. And now I'm going to create one more container, but I want to run in interactive mode -it. So docker run -it followed by that image name in bash terminal. Simple. See here, now we are within the container. I can able to explore this particular container. I can able to verify the components. Like I want to check whether Git is installed in this container or not. If it is installed, I can use it. Otherwise, I can install it, right? So what are the tasks I want to perform, and I can able to perform inside the container, and I can able to exit from that container. That's it. So this is a way of running the container in interactive mode. So we have some images, right? If you want, I can give a run command again, docker run -it. In interactive mode, I want to run this Ubuntu, okay, in a bash mode using this bash terminal. So Ubuntu is the image that is present in a container registry. We haven't downloaded to a local machine. So usually if you want to download the image, what is the command we use? It is a pull command. So instead of pull command, if you directly use a docker run command, first it will search that image in a local machine. If it is not present, it will download from the container registry. See here, it is unable to find that image locally. So it is trying to pull it from the remote repository, and it has created one container out of it, and we are just within the container now. I'll create a duplicate terminal and we'll see that. See, we are inside this now. All right. So it is running this in an interactive mode, and you can able to explore this container. Like if you give a ps ls command, you can see the file system. And if you want to verify the packages, anything is available there, you can verify. If not, you can able to install it. Apt update -y. You can update the packages. You can install Git, you can install Maven, you can install Tomcat, anything, right? So I'm installing all these things. Similarly, you can able to install, let's say I want to create this container for your build environment. I want to create a dedicated build environment using the container means I can able to use that as well, right? So like this, at any point of time, we can able to create container and start running it. See, this is a command we can able to. I just use a command, cat command, followed by that release. So I just want to capture the complete architecture related, OS related details of this particular container. See, it is running with Ubuntu 24.04 version, right? So this is how it is. Similarly, if you log into your CentOS, let me exit from here. And if I use a command docker run -it CentOS, and if I use that command here, see, this is something related to your CentOS version. Correct. This is what you're expecting, right? So like this, we can able to run the containers in an interactive mode, and you can able to install the required packages, and you can able to perform all sort of builds and take a backup of it. And once the process complete, just exit from that. That's it. And once you exit, the container, whatever you have created, it will be available in your machine in the exit state. It is present in your machine in exit state. And if you noticed, in this Ubuntu container, I have installed Git, right? If I create another container using the same Ubuntu image, I have to start everything from the scratch, because whenever I create a new image, right, it will create from the scratch. But if I want to use this particular container again in my local machine, I can use a command called docker start followed by the container ID. So docker run command is used to create a container, and the docker start command followed by the container ID. So this is to start a container. You see, so it is used to start the container which is already in exit state. So if I run this command, it just starts. And now if I say docker ps, I can see this container is up and running. The same container ID, whatever we have created earlier, it is up and running. And now if I say git version, it should be available because already I've installed it in my container and I just stop the containers in exit state. And at any point of time, I can start the new start the same container. I can perform the build, create the artifacts. Once artifact created, I can stop the container. So to stop the running container, we can use a command called docker. Sorry, I think it is not logged in actually. This command is at the host level, not the container. Can you see this? This docker start command, it just started the container. It doesn't mean that we logged into the container. There are two things to consider here. This is just to start. Similarly, if you want to stop the container, you can use a command called stop. Okay. But before you stop the container, if you want to access, if you want to log into the container, there is a command called docker exec command followed by the container ID using a bash terminal. So this is to log in to the running container. All right. So I have just started this container docker ps. This container is up and running, and my requirement is I just want to log into this. So what I can do here is I can use docker exec -it in interactive mode. I can use a container ID and using a bash terminal I can able to log in here. See, if I say version here, I should be able to access it now. Sorry. So the purpose of docker exec command is used to log into the running container. And once a process completes, you can simply exit, that is log off. This exit command is not used to stop the container or exit from the container, just to log off from the container. If you check the status of this container, it is still up and running. So if you want to explicitly stop the container, you use a command called docker stop followed by the container ID. The properties of these containers, that is the scope of the containers, are within this machine. For example, the containers, whatever we have created here, the scope of these containers are within the machine. So within the machine, you can able to start these containers any number of times. You can able to access any number of times. But if you want to port it, if you want to transfer it to any other machine, it is not possible because it is a process. So that is the reason we create an image out of it and share that image to the container registry. And from the container registry, anyone can able to pull and run that container. You see, I'll show you how to create an image, how to push it to the containers, and all. We'll see one by one. Like this, we have another important thing like docker images. So there is a command called docker rm command. Rm means remove. If you want to remove any container from your local machine, you can simply use the command docker rm followed by the container ID. See, that container has been removed from the list. Okay, like this, if you want to remove more than one container, just specify container ID, giving one character space. So if there is no task, it exits by default, right? That is exit code 0. Or if you explicitly exit from the container after a task completion, or whether you use your stop command or exit command directly to exit from the container. It depends upon the state. There's a lot of status code that defines the exit state of your container. And not only this, at any point of time, you can able to create a container and you can able to tag it. This is the naming. You can see the names are automatically assigned randomly, right? So I'll show you how to create a container with a unique name also. But usually when it comes to a deployment perspective, we never use that. If you want to name any container based upon your team or based upon any of your prefixes, you can able to attach the name for the container as well. So now you can see using docker rm command, I can able to create more than one container that is present in my local machine. Similarly, there is another command called docker rmi command. This is to remove any image. So if I use docker rmi followed by that image name like CentOS, see what happened? It says there is a conflict. Unable to remove the repository reference CentOS because the container is using that actually. So that means this particular container, whatever we have created, it is still referring this particular image in the local machine. So if there is a case, you delete that image by default. If you want, you can go with a forced deletion, or you can first remove that container and then remove that image. So there are two options available. Either you can go with a forced deletion, or you can first remove that container that is referring that image, and then you can able to remove that image. So now it is successfully removed. And if you say the list here, you can able to see this Ubuntu alone is available. So the next command in the list is about docker rm followed by that container ID. While referring the object, either you can use your container ID or container name. There are two entities here, right? Name and ID. You can use any of these things. Similarly, while referring the image also, either you can use this or the image ID. Depends. So rm is to remove container. And similarly, we have something called rmi. This is to remove the image. Okay. So like this, we can able to remove this thing. And I was talking about the force removal. Remember, when the container is already, when the image is already being referred by any of the containers, you cannot delete that image by default. So there are two options. Either you clean up all the containers and then delete that image, or you have a command like docker rmi. For -f followed by the image ID. So this is the force removal. But usually it is not recommended to remove it forcefully. If you want to gracefully remove that container image, just delete all the unwanted things and remove it. Otherwise, it might create a conflict while handling that container in future. You have to explicitly download again. So it is not recommended to download the image each and every time, because each and every container image has its own volume, right? Consume its own volume. So let's say this Ubuntu is just 78 MB. So whenever you use a docker pull command, you are just downloading 78 MB, right? So in order to prevent that, once it is downloaded, keep it in local machine. If it is no longer required for sure, then only you can go and remove it. See, the CentOS image is of 231 MB. So all these things has to be taken into consideration while handling the images, right? So this is about your creation of containers and deletion of the containers. Now, the next important thing is, as I said already, whenever we run any container, the container run in its own address space by default, right? It run its own address space, isolated path, we can say. So when we say an isolated path, the application that is running inside the container, it is limited within that container. For example, consider I have a VM. In this VM, I can install Tomcat, right? Module. In the last Jenkins module, we have installed Tomcat in our QA server, remember? And it is a web application server. So once I install this, I can able to access this web application using the external IP address of the machine followed by the port 8080. Remember, since we have installed this Tomcat directly on this VM, I can use the external IP address followed by the port number. This port number is associated to this VM. There is a host machine. But now the point is, I'm going to have a VM. In that VM, I'm going to create one container. And in that container, I'm going to run a Tomcat application. So which runs in port 8080. So the port, whatever we are referring here, it is a container port, not your VM port, because it is running inside the container. So my requirement is the application that is running inside the container, I want to access it through internet. I want to expose this container to multiple users through web browser. If I want to access this, how it is possible? By default, it is not possible. Why? Because the property of a container is the scope of the application is limited within the container. Even the neighboring containers or the underlying operating system will not have any clue about what you are running in that container. So if you want to access your application through internet, you have to expose that container port to your host port. This is a host machine, right? Every host machine can be enabled with the port number, and you can able to expose it to your host machine. So that's what the concept called port mapping, or we call it as a port binding. It's a very important topic. So let's say, for an example, consider, I think already we talked about the Tomcat image. Remember, we have a Tomcat image available, and I can directly use this Tomcat image now. So let's say we can use any version of the Tomcat. Like it can be your 8.5 version or 8.0 version or 9, anything as per your choice. So let's Docker images. Let me create one new, download a container and run it now. So if I say Docker run -it followed by the image name like Tomcat, and I want to specifically use a version, anything like 8.0, something like this. 8.0 is available in the container registry in a bash terminal. See, it is unable to find that image in local machine. So it is pulling it from the container registry and starting the container in an interactive mode. This is the default directory for your Tomcat image. And now if I say ls, I can see all the components of your Tomcat web application server. And if you notice, there is a web apps folder also. CD to the web apps folder, and you can able to see that particular application component. But whether it is running as a web service or not, no, it is not running as a service now. Why? Because when you start the container, I just started in interactive mode, and I'm using a bash terminal. So if I get into this Docker PS, you can see one container is up and running. One container is up and running, but it is not running any service. Okay, because we are just overridden this command at runtime. If you see the actual property of this container, image, Tomcat container image, it is having various instructions, and the last command is catalina.sh, the script that is used to start your Tomcat service. We just replace the script with the bash command actually. We just started the container running interactive mode. That's it. So if you want, you can simply say stop or exit from here. That's easy. And another important thing is, if you want to run the service, Tomcat service means you can simply use a command docker run -it without any runtime command. You can give it. It can be interactive mode also, that's not an issue, but without giving any commands, if you simply use docker run followed by the container image, see, it has started this in an attached mode and the script has been executed. So now my Tomcat service is started. It is up and running. If you see the process, see now this service is up and running. The catalina.sh script, it has started this service. Easy. But the scope of this Tomcat service is within the container. I cannot access it through my web browser. Okay. So how I can able to access this? What are the process behind This means we have to enable some port numbers. Say for example, if you go to your instance, this is my node where I'm running my container, right? So just go to the security group of this node first and update the inbound rules, add some port numbers. Like I want to do some port mapping. So for a sake of demo, I can allow all traffic for now. I just enable all the port numbers just for sake of demo. In real time, we never do this. Just for sake of demo, I just enable all traffic for now. Now, what I can do here is I'm going to work on this port mapping. Port mapping means it is a process of mapping your container port with your host port. For that, you use a syntax like this: docker run command. It can be interactive mode, that's not an issue. -p. P means publish your host port 8089 or something like this, colon 8080. Followed by the image name, something like Tomcat 8.0 only we use, right? Okay, that's it. In a bash, or it can be like this, normal. So what I'm going to do here is I'm trying to start my Tomcat in an interactive mode with this simple port mapping. So the syntax here is port mapping be done using -p. -p means publish, followed by the host port colon container port. That's it. So always remember, first you should give your host port number 8089, which I just enabled through this inbound rule. It is available, and this 8080 is a container port which is defined within the container. So if you can see this Tomcat container image, it is exposed to 8080. That is the default port for Tomcat. So now, once this is available, I can able to create one new container now. It's already up and running. If you want, you can stop this. Okay, unnecessarily why to run this, right? So let me go ahead and stop this docker. Stop followed by the container ID. Just observe the field, okay, the port field, whatever we are seeing. That's what importance now. So here you can see we have stopped this. Let's start it again. But now this time, while starting this, I want to use a tag -p. -p, what is the first value? It should be your host port in your machine, colon your container port. Container port is always 8080 as per the image. If you want, you can able to customize it at any point of time. That's it. So now if you run this command, you can see it has started the script and your Tomcat service up and running. So we have installed Docker in our Jenkins slave node. In the slave node, we have installed JDK, Git, Maven, and then Docker engine. We haven't installed Tomcat on this VM, but we have created one container, and that container is running this Tomcat image. So if you can see here, this container, whatever we have created, it is enabled with the port mapping. This is a host port and the container port. Now, what I can do, I can use the external IP address of this machine, copy the external IP address of this machine, and you can give port 8089. 88. See, I'm able to access the default page for Tomcat. It is not actually installed on our VM. It is running inside the container, and using the port mapping, I'm able to access this. Okay, let's say I want to run the same command again in this terminal. Let me start this with a different port number 8089. So in this case, if I run this command again, it is running. So it means within the same node, I can able to run two different services using different port numbers. This is by default not possible with your VM. If you directly install Tomcat on your VM, you can run that in one particular port number 8080 or any other custom port numbers. But now through containers, I can able to run multiple services. So assume that this is my test environment now. So my testing team can able to test multiple application services by running it multiple port numbers. Things are clear how to expose your applications to access to internet. If you have a valid image, if you create an application image, means you can use that image and run your application directly here. I'll show you the next step. I'll show you how to build your images and all. So this is about your port mapping. And this is just an example, okay, with the base image. Tomorrow, once we start creating our own application image, like for example, in the last Jenkins module, we created one web application artifacts, right? So using the application artifacts, we can create one image, and that image can be executed using this Tomcat. And through port mapping, you're able to see how we can able to handle it through your web browser. It's possible. So it means in this architecture, we have a VM, and in that VM, we are running container 1, Tomcat container 1, and Tomcat container 2. So this is running in port 8088, and this is running in port 8089, correct? Similarly, if I run the same command again, what will happen? Already we have containers. We have two containers up and running, and now I'm going to create one more container. Will it be successful? That matters. So the host port, whatever I used, 8088, it is already referred in this particular container. So we cannot run more than one process with the same port number, right? So it fails. So while creating a container, please ensure that the port is available for access. That's the reason for the matter of time, I have enabled allow all traffic and I have all ports available now for my execution. But in real-time environment, you can able to enable some range of port numbers based upon your company's security policy. It will be assigned by you. All right, that is all about the port mapping, and it's a very important topic through which we can able to create some 3D applications, enable some communication in the containers, everything will see. So another essential thing is about the log actually. Okay, so let's say I have a container up and running. Okay, so you can use a command docker log. So it will be very frequent activity which we do in real-time environment. Sometimes what happens, application team, they must have deployed something in the target machine. Like, so I just given a command docker log command. So once you give a docker log command, what happens, it just generate a log. Let me show you again, docker ps. Okay, so we have these two containers up and running. Most of the time what happens, we get a request from the application team stating that their containers are up and running, but they're not getting any response from the application. So in such situations, we can understand, get into the container, like this is a container ID, and I can able to explore what exactly happened to this container. So for example, I use a command docker logs followed by the container ID. See, when I run that command, I can able to actually get into that container and examine what exactly happened in this. Our main focus will be in the Tomcat application artifacts directory, like where we have a web app up and running. So this one. So we need to check whether the latest version of the artifacts are loaded into this directory. As I told you, sometimes they might not get the response or they might not get the latest changes. Response means the response from the latest changes. It might be focusing or capturing the previous version of your application artifacts. So they might have forgot to update latest version in that image. So you can simply use a command docker logs command to capture the container log, and we can share it with your application team for diagnosing purpose. So syntax is docker logs followed by the container ID. Right. Easy. So port mapping and then logs. It's all very frequent activity which we use. Easy. Like this, there are a lot of things. Okay. -q. See, if you use a simple docker ps command, what happens? If you simply use a docker ps command, you can able to get the process, container details, everything. But I just want to know the container ID alone. I can use -q. So I can get the list of container IDs that are up and running actively. Okay. And sometimes what happens, we need to manage the container volumes. We have a separate concept called persistent volumes in containers. So I think we can talk about that in next session. So we have something called Docker volumes, and we'll see how to work with Docker Compose, and we'll be discussing about container orchestration. Like here, if it is a Docker based containers, we'll be using your Docker Swarm for container orchestration. And apart from Docker Swarm, we have something called Kubernetes. Okay, Kubernetes is also a container orchestration tool. We'll be focusing more on Kubernetes. We'll be having just the overview of Docker Swarm. I'll tell you the reason in the next session. As far as Docker is concerned, the very important thing is the Docker build. We'll see how to create Docker container images. So for creating a container image result, we have two techniques by using Docker build, or I can first talk about Docker commit and then Docker build. So using these two CLI commands, we can able to create an image, because so far we are using the existing images like your CentOS image or Ubuntu, which is already there in the container registry. Next, we'll see how to create our own image. And then once the image is created, we'll see how to publish or push the container images to container registry, right? And then we'll talk about the volumes, doc compose, and then we get into the container orchestration tool. So these are all the commands we have executed in this terminal. Let me, starting from here. For the installation, I have already given the command in this document itself. You can use the same. Like I was talking about this apt install, right? Just as a root user, run this command. It will install Docker. And so hope this will be helpful for you to practice, right? I think we have included run command with the Tomcat, stop with port mapping. Yeah, that's fine. I think we have the commands. Almost everything is available. And not only this, in my class notes itself, I have added those commands with the syntax. So you can refer to that as well. Yeah, we'll talk about all these things in the next session.